Welcome to this video on completing the square. In this video we're going to have a look at 3 examples, 2 of which are trivial examples of how to factorize by completing the square, and the third one we're going to factorize an equation, a parabolic equation that isn't necessarily a trivial factorization using the factorization of the square method. Now, looking at the first one, if you remember the factorization using sum and product, if we were going to factorize y equals x squared minus 6x plus 9, what we ask ourselves is this negative 6x, what two numbers add together to give negative 6, and what two numbers multiply together to give 9. So the way I would approach this one, assuming that there are going to be integer answers and real roots to the equation, I would say, what are the factors of 9? And in this case, 9 is going to be 3 and 3. So then I'm going to ask myself, well, if 9 has factors of 3 and 3, how can I make them add together to give a value of negative 6? Well, what we can do is we can say, well, the factors of 9 are 3 and 3, but it could also be negative 3 and negative 3. So this will become x squared minus 3x plus 3 squared. Perfect. Now, factorizing in these first two terms here and these other two terms over here, we're going to pull out a common factor between these. So looking at this, there's a common factor of x, so let's pull that out and we'll go x minus 3. Now going over to these green ones, we can say, what can we pull out to get a factor of x minus 3? And we can pull out negative 3. So negative 3x divided by negative 3 is going to leave x, and negative 3, or 3 squared divided by negative 3, is going to be negative 3. So I'll get rid of my positive there, and therefore we can simplify this down by taking out a factor of negative, or x minus 3, which would be x minus 3, leaving behind the x here and the negative 3 here, and therefore notice it's x minus 3 times x minus 3. We can simplify that down to x minus 3 all squared. And would you notice that this x minus 3 all squared is indicative of the perfect square over here, so the x minus alpha all squared. So as I mentioned, this first one is like a trivial example in that it's a perfect square. If we can see that the factors add together to give, oops, I used my mouse. If we can see that there are two even factors that multiply together to give this c value here, and that add together to give the b value here, then this is a perfect square. Now going down to the next one, we've got y equals x squared plus 6x plus 9. So can you notice the pattern? Well, going across again, we can see that the 9, the factors are going to be 3 and 3, and the two 3's, they can be added together to give this 6 in here. So rather than doing all the steps that I had already done in the first example, let's skip a few just for the sake of time. So x squared, and I'm going to simply represent this as two 3x's, and then this 9 here, I'm going to represent that as a square as well. And simply looking at this form here, we know that it's going to be a perfect square because these two numbers, they can add together, and if they multiply together as well, it's going to be here. So we can simply state that the equation for this, or the solution, factorized solution, will be x plus 3 all squared. Awesome. So again, satisfying the form of the perfect square over here. Now consider another example. Let's say, rather than 35, let's say it's 10. So in the previous example, the constant was 9, and in this example, it is a constant of 10. Now there are two ways in which we can go about this. The first one is, if we want to get this in a form that's easy to work with, what I could do is simply say x squared plus 6x plus 9 plus 1, and simply ignoring this 1 for a little bit and looking at what's inside the parentheses here in red, we could factorize this part down here simply by looking at our previous form, or the previous example, as x plus 3 all squared, and then the loner of a 1 constant at the end. So that's one way we could look at it. Another way we could look at it where we don't actually know, or this actually isn't going to cooperate as easily, is we could say y equals x squared, and then I'm going to split this coefficient of 6 into 2. So it will become 6 over 2x plus 6 over 2x plus 10. Now the next step is I'm going to introduce a new constant, or in fact I'm going to introduce two new constants equal in magnitude but opposite in sign. And what it's going to be is, firstly simplifying this down to the 3x's, I'm going to introduce it such that it will be this 3x squared as a plus, and we'll put a parenthesis in there to block everything off. You might have figured out what I'm doing. And then another 3x squared but opposite. So this one over here, this one here, notice it's a positive 3x squared, and the other one, which I've created, it's a negative 3x, it's a 3 squared and a negative 3 squared. And you might be thinking you can't just pull numbers out of thin air, and you're definitely right, but consider, because I've pulled two numbers together, or grabbed two numbers, notice they're equal in magnitude but they're opposite on the number line. So if we added the 3 squared and the minus 3 squared together, it would actually equate to a net value of 0. So although there are new numbers in there, I didn't actually add anything to the equation or change any values. We simply made it such that we've got something to work with. And finishing it all off, I've got to drop the 10 down there. Now, notice in the red parentheses, we've dealt with this before. We know in here this is a perfect square, so we can rewrite it as such. It will become x plus 3 all squared. And then we've got to deal with this negative 3 squared. So negative 3 squared plus 10, going down to a new line, x plus 3. And then I'm going to break this open, and it will become negative 9 plus 10. Finishing it all off, y equals x plus 3 squared, and negative 9 plus 10 is simply 1. So in the first example on the left here, we broke up the constant such that we could easily factorize down to a perfect square. And then in the second one, we didn't break the constant up, but rather we pushed it to the side and pretended it wasn't there. And then we added two constants, both equal in magnitude but opposite in sign, and we chose the value of the number we were adding as, or the square of half of the b. So the square of half of the b, or the coefficient in front of the x, which was 3. Then we turned inside these parentheses into the perfect square, and then dealt with these, I guess you could say, residual constants at the end, so the minus 3 squared plus 10, which all factorize down to what we had on the left hand side here, which is in this form, y equals x minus h all squared plus k. Now you might ask yourself, what is the purpose of this tool? What or how does it benefit us? And the answer to that is, firstly, there are two reasons. One is because we've got it in the form of a perfect square, we could rearrange this equation here such that x can become the subject. Now to do that, we can say y equals x plus 3 squared plus 1, moving the constant over to the left and then flipping everything around, because we want to have x as the subject, be x plus 3 all squared y minus 1. Then I'm going to take the square root of both sides, x plus 3 y minus 1. Notice because I took the square root, it's going to be plus or minus, and then simply cleaning up this constant of 3 such that x becomes the subject. I'll take 3 from both sides, so that'll be negative 3 plus or minus y minus 1. Awesome. And the second benefit of being able to complete the square in a form that represents this or even this is that it actually makes it really easy to graph. So if I draw a Cartesian plane, putting arrows on all of my lines or axes, and that's y plus and this is x plus, I can say that, let's assume that, in fact no, we won't assume, we'll just say, we'll graph this one. Notice that there's h and k. Well, what this h term does is it shifts or it translates the graph left and right about the x-axis. So it translates to horizontally about the axis. A positive h will move it to the right and a negative h will move it to the left. Similarly, the k constant here, it actually translates the parabola up and down, or it translates it about the y-axis. So a positive k is going to move your parabola upwards and a negative k is going to move it downwards. Now, the values themselves, it's going to be, so this should be, as I mentioned, for a positive h, it's going to move it to the right, but notice this is plus 3 and the form itself is negative h. This h here, it's actually a negative 3. So it would be written like, whoops, negative, so negative, negative 3. And what that will look like is the vertex will be there and go upwards like that. Now I got my scale not very great here, but the vertex itself will be at negative 3 and positive 1. So this completing, or this form we get into from completing the square, it actually makes it really easy to graph parabolas. So it's really important that we learn this tool because this will just give us more options to be able to manage, I guess you could say, polynomials of order 2. So if this helps, then awesome. If you would still like some more examples of how to do this sort of question, then not a problem at all. It's definitely not an easy thing when you're seeing it for the first time, and it can take a few different examples to be able to get everything down packed. So if you'd like me to do some more videos on this, then please let me know, and that is definitely an option.